Bismillahirrahmanirrahim. So we are toward the end of the course, and today we will talk about the design of photovoltaic system. Like if you want to install at your house the photovoltaic system, like what should be the size, what should be the number of photovoltaic panels, and which direction you should be facing it. So this lecture will cover that. Let us have a look. Like what we are going to cover in today's lecture. We will learn about how to estimate the household load and how do we do the site assessment. Then we will do some calculation on finding the photovoltaic sizing, number of panels required, and tilt optimization. Then we will talk about some shading analysis and seasonal performance. That one we will just touch the topic, and we will also introduce you to some software tools, but I'm sorry, we are not going in details about each of these software, just to let you know the available software names. Now let's start with the load estimation, right? It's always best to get the manual method, or you can actually make an average idea from your electricity bill from the household, how many kilowatt hour or watt hour you need. Okay, so this one we were first going to list all the electrical appliances and their loads. Then we have to find out the rated power, the wattage, and how many hours we are using it, right? For example, if you are using air conditioner in summer, you have to know the power rating of the air conditioner and for how long you run it. Then you multiply the wattage with the hour, you get the watt hour energy. So daily energy demand will be summing up of all these watt hours from different appliances. And then on top of that, you have to add some system loss, because when you are attaching the photovoltaic, there will be the wiring, and through the wiring the electricity is flowing, so there will be some resistance loss, and all. The longer the wiring is, this loss will increase. So we have to consider about up to 20 to 30% of this system loss. So there is an example of you how do we do the manual estimation of load. Like if you have a two-bedroom house, so you have like living room lighting, the voltage is 12 volt, then how much power it is drawing multiplied by current, you get 11 watt. Like when you attach the light bulbs, 11 watt. Kitchen lighting, hallway lighting is 8 watt. Bathroom lighting, bedroom 2 lighting. Then if you have a porch for the car, outside porch lighting. Small fridge, if you're using a small fridge, TV, laptop, computer, charging cell phones. And there is some phantom loads also that we are like, that is considered as the losses. So how do we find the kilowatt hour or watt hour? We find how many hours they have been used, the living room light, kitchen light, hallway light, all these lights. Okay, these are for small appliances only. We are not considering the aircon or the fans and other stuff. So for your area's perspective, what are the appliances, and then how much is the rating, you can do it yourself. Then how many hours they have been used, so multiplied by the wattage will give you the watt hour. Okay, then you sum up all the watt hours, so you can find 662 watt hour. So this is my daily requirement. We can start based on this daily requirement for the calculation. But in the next slide you will see that I've just used from house's electricity bill for the whole month. Then we can also make it per day. That one is also a quick way to average if you already have the installed house with the power supply system. So you just take the electricity bill and find how much kilowatt hour you have used. So for one day on an average, how much would it be? Then comes the site assessment. We have to measure the solar irradiation, and another important thing is we have to know for how long we are having the full sun. Remember sun peak hour, solar peak hour, we learned within lecture 2 3 the solar peak hour, right? So we need to know about that, how many hours we are getting the sun, and also kilowatt hour per meter square per day. We have all learned these measuring methods at the beginning. Then we have to find the roof orientation. If it's a flat roof already, then you have to do the alignment of this photovoltaic. If it's already a roof, inclined roof, then you just have to like set the photovoltaic panels on the inclined roof, right? Then check the shaking obstacles. Where are the trees and nearby buildings? So we don't want to go and set our photovoltaic panel there. And also obviously you have to evaluate the local weather and seasonal variation, right? Because during winter and summer, the sunlight will actually be different, right? The angle of inclination will be different. So we have to consider that one also. Now, let us start with the photovoltaic array sizing. So what are the steps? How do we follow? We are going to see it through a worked out example that I have extracted from ChatGPT for a lump sum value of the daily average requirement. So calculate the daily load, watt hour per day or kilowatt hour per day, then adjust for the system losses. So we will need something called performance ratio for different system. Depending on whether it's standalone or it is grid connected, that performance ratio will also change. Then divide by the site solar insolation, okay, to find the array size, and then select the number of modules, the photovoltaic size divided by the module rating. Then we can actually decide on how many modules we will need. Then based on each module's area, we can find how much total area we need to occupy on the rooftop. So there is this worked example. This one is like I just provided the value of my house's monthly kilowatt hour usage. Okay, so my house, from my electricity bill, I extracted that I use 660 kilowatt hour per month electricity. So Malaysia is a hot country and we do run the air conditions, refrigerators are continuously running. So I mean our house load is moderate, like not very high, not very low, moderate. Sometimes we run the oven, and those days the oven, when we are running the electric oven, then the electricity consumption is higher. Vacuum, so these are the strong power equipment. The vacuum cleaner we use is like 1500 watts. So even if I run it for half an hour, I'm consuming at least 0.75 kilowatt hour, right? So depending on this one is a standard household in Malaysia, so it's 660 kilowatt hour per month. Now if I want to supply this whole 660 kilowatt by all the solar panels, it's actually too ambitious design. Okay, so I just used half of this. So 660 kilowatt, so daily average will be 22 kilowatt hour per day, considering a 30 days a month. Then I want to supply 50% out of it. Okay, the rest 50% will depend on the electricity supply. So 11 kilowatt hour per day. Okay, so I will be running 11 kilowatt hour per day personally from my system, and the rest I'll be relying on the other, on the power supply board. Then this average full sun hours or those peak hours, 4 hour per day in Malaysia. Performance ratio, that means it's depending on the losses, right? Losses due to different kind of wiring and different connections. There are some losses. So for a standalone, I'm going for a standalone. I've chosen a standalone off grid. So I'll need a battery first of all. And then for the standalone, the performance ratio is lower. Okay, this one is lower. For a grid connected, it can go up to 0.8 or something, because for standalone you have to set up for the battery, and all this wiring will cost you the drop in this PR value, performance ratio. Then panel size, I initially select like 400 watts per each panel, and each panel has a 1.9 meter square of area. This one is available in Malaysia, so depending on that I just picked 400 watt each. Inverter efficiency, just taking 95% within a standard range. And battery depth of discharge, DOD. It means how much of the battery will be discharged. So lithium ion is 90% and lead acid is 50%. So I consider I'll just see like which battery I'm going to connect to, and then 1 day of autonomy considered. 1 day indicates that I will be running on the battery for 1 whole day completely. In any case of any emergency issues or anything, I will run this 11 kilowatt hour per day for the whole day using that battery. That battery is capable of supplying me 1 whole day of 11 kilowatt hour charge. Okay. Then we start by finding our basic load. 11 kilowatt hour I need to supply from my photovoltaic using a standalone method. So the kilowatt power, okay, kWp, this one is the maximum power available in watts from the photovoltaic. Okay, so this one is basically the rated maximum power output of a PV module under the standard testing conditions. That means your solar irradiation will be 1000 watt per meter square, temperature is 25 degrees Celsius. Under this, it's the rated one. So at this price, when the manufacturer is selling to you, they will use this kilowatt power. But previously we have learned about MPP, right, maximum power point. That one is actually coming from the operating point on the IV curve of a PV module, where it delivers the maximum power under the real condition. So MPP is the real condition, KWP is the standard, okay, for selling. If you are telling that you're going to sell at the MPP, nobody will buy your thing, right? Because MPP is lower than the KWP. The number of panels. So first we determine what is the kilowatt power is 11 kilowatt hour per day divided by the sun hour, which is 4. So kilowatt hour divided by hour, only remaining is kilowatt, but I won't be able to get it directly because there is some losses, so I have to divide by the performance ratio. Then I get that it's 4.23 kilowatt power or 4.25 kilowatt power. So this is the under standard condition. I need to generate this amount of kilowatt if I want to supply 11 kilowatt hour per day for my household. Then I can, from this kilowatt power, so this one is the standard rating, and I am planning for the standard panel size 400 watt. So if I divide 4.25 kilowatt power by this 400 watt or 0.4 kilowatt, so this one is 0.4 kilowatt, I get 10.6 panels or 11 panels. Okay. Then roof area, I require from the roof area is each was 1.9 meter square area for the panel multiplied by 11. I will need in the roof area approximately 21 meter square, but we always keep some spaces for like properly installing them, so we can actually plan for slightly higher than that, 22 to 25 meter square with spacing. So we have seen how many panels we need and how much area is needed. Now let's have a look into the battery sizing. Okay, considering the 1 day autonomy, that means the thing can run for 1 day whole depending on the battery. Okay, so energy required from the battery with considering the inverter efficiency will be, instead of 11 kilowatt hour, it will be more than that, because the inverter will not be able to convert 100% of the DC current to AC current, right? So this one is like 0.95 is the inverter efficiency, so I will have to from the battery I need to supply 11.58 kilowatt hour, okay, to get 11 kilowatt hour at the user end. Now if you are using lithium ion battery, which is expensive, but we consider like 90% of depth of discharge, that means I'll be able to extract 90% from it. Now what is this depth of discharge? It's a measure of how much of a battery's total capacity is used. So if a 10 kilowatt hour battery with 50% DOD or depth of discharge is used, it means 5 kilowatt hour has been discharged and 5 kilowatt hour is remaining. So that means 90% means I'll be extracting 90% of the battery's stored energy. So it will be 12.9 kilowatt or 13 kilowatt hour nominal. The battery size should be able to store up to 13 kilowatt hour depending on the depth of discharge. And if you're going for a lead acid battery, so I'll be extracting 50% of it, then it will have to go for 24 to 25% carrying capacity. Okay, 24 to 25 kilowatt hour carrying capacity. Then for your system summary, now we have gone through the sizing, battery, okay, just a initial, it's not very much detail, it's an initial one. So we have learned at least that, okay, if we know the load, we can, if you do not know the load, we can calculate by identifying each of the electric appliances and their wattage and their usage time. And if you have your electricity bill, then it's a clear-cut case. You can just average it per day use, and then based on that you can find the kilowatt power. From the kilowatt power, depending on your selected size, selected capacity PV panel, you can get how many number of panels you'll get. Now we have used the 400 kilowatt PV panel each. If you are using 300 kilowatt, then you will require higher amount of photovoltaic panels, right? Okay, so you'll need a higher area on your rooftop. So daily household use is 22 kilowatt and I want to supply 11 kilowatt standalone. So the PV size is 4.25 kilowatt power. This is called the array size, 4.25 kilowatt power. And panels we require are 11. Okay, roof area required is 21 meter square. And battery is 13 kilowatt hour if you're using lithium ion with 90% DOD, and if you're using lead acid with 50% DOD, it will be 24 to 25 kilowatt hour nominal. Inverter is like 3.5 kilowatt, recommended 5 kilowatt, that one depends on the design. Okay, and charge controller is either equal to or less than 100 ampere at 48 volt MPPT, so considering the maximum power point tracking condition. And a recommendation is like inverter should match the peak load demand, right? So when the peak load is occurring, the inverter should be able to convert it. For 2 days autonomy, double the battery size. If you want to run for 2 days continuous, depending on the battery, then you have to double the battery size depending on the battery type. Now, what if it was a grid connected system? For the grid connected system, the main change will be, first of all, no battery. And then another one is the PR, performance ratio, will increase because no battery means lesser wire. And I'm not talking about the supply to the grid here. I'm focused on my house, and then in that case the PR itself will increase because I have cut out the battery sizing and battery wiring and everything. So therefore we will be able to save up with the number of PV modules needed, and hence we will have slight saving in the space required. Okay, now we are going to have a look at how can we optimize the tilt angle, like at what angle we should place the PV panel to capture the maximum of the solar irradiation, right? So the rule of thumb is the tilt is the latitude of location. So you have to tilt it according to the latitude of your place. I believe Gaza is at 31 degree latitude. Latitude is, by the way, the horizontal line across the earth. So these are the latitudes. So 0 degree latitude at the tropics, okay, and the longitude are the vertical lines. So at North Pole is 90 degree north latitude. Okay, so latitude should be north or south, and so forth. But there's another thing, like when the earth is revolving the sun, depending on the distance, the winter and summer is determined, right? So because earth itself is 23.5 degree tilted, So during winter and during summer, we actually do some further optimization. So during summer, we minus 10 degree from latitude, and during winter, we add 10 degree to that latitude value. So tracker improve yield, but increase cost. Definitely, if you're attaching the tracker, so it will always be tracking the sun, it's going to be costly. Now let's take Gaza City as the example. Latitude of Gaza City is 31.5 degree north. Using the rules of thumb, so our inclination angle should be, the tilt angle will be 31.5 degree all year fixed if you want to go for a fixed tilt. Okay, facing the true south. Now during summer we can actually tilt it negative 10, 31.5 minus 10 degree, 21.5 degree is going to be flatter to capture the higher summer sun. And during winter we need to push it upward, 31.5 plus 10 degree, 41.5 degree, so it will be steeper to capture the lower winter sun. So if a system in Gaza is mounted at like around 32 degree tilt, it's a good compromise for the whole year if you want to avoid the tracking system. Okay, and if you can actually adjust, then it's better. Like during summer, the summer months, you put it into 22 degree, and during winter you fix it to 42 degree. Now we need to know about the shading. Okay, shading is like a common phenomena, but we should not be installing our photovoltaic panel near any place where there is a confirmed chance of shading. That means we should avoid near trees, poles, or like the buildings. Okay, so all these things we need to carefully see whether they are creating any shade, because if there is a shade, even a small area of shaded condition will cause significant drop in the output voltage and current. So the thing is, because there are small photovoltaic cells all arranged in array to create the photovoltaic overall panel, right? So if one cell is shaded, then it won't be producing any current. Instead, this one will act as a hot spot because it will start to get heated. Right? So that can be another concern when there is particularly shade on an even small area. So we should be also tracking the sun path diagrams, and bypass diode is an important element here. This bypass diode is a small diode. It is connected in parallel with a group of solar cells, right? So maybe it covers like up to 18 to 24 solar cells is covered by one bypass diode. It normally works as a reverse biased. That means as long as the photovoltaic cells are getting enough light, it won't do anything. It will just do nothing. But when the shading will occur, the bypass diode becomes forward biased, allowing the current to bypass the shaded cell group. So since all these photovoltaic cells are in series and one is not generating current, so it is supposed to break the circuit, right? But if you have the bypass diode parallelly connected to all these number of photovoltaic cells, then it will be bypassing the non-active solar cell. Okay, and then it will allow the current to bypass the shaded cell and it will come to the main supply. So since solar path actually changes along the season, so energy yield also will vary along with the solar path. So solar energy is a weather dependent energy, we can say that, unless otherwise you are staying in a very steady climate zone. So if we consider the longest load demand period, winter in temperate regions where the temperature is not extremely high or low, but they have variation in temperature, winter in the temperate regions and rainy season in the tropics. So these are the longest load demanding period. Okay. So in this case, what we can do maximum is doing the panel tilt orientation adjustment will help for taking care of the seasonal performance. Previously, you have seen for winter, we add up 10 degree and for summer, we negative minus 10 degree, right, for the tilt. So this kind of tracking can help. Now we will get to know about some of the software that is used for the photovoltaic system mostly. Some of them are extended to thermal system as well. So this part I will just introduce you to the names of the software. I have provided the links and the YouTube channel, official channel. So if you are further, like after you graduate, if you decide to work on this area, this course was very much introductory course. So if you really want to go deep into this, maybe in the normal condition, if I could teach you directly in your place, maybe we would be getting more of this if everything was all right. But now the situation is different. So I will be just introducing you to the names of the softwares. It is up to you. There will be no question from these softwares, but it is for your own interest. Later, if you move into the solar industry, you can actually scan through this. So one is a PVC, the most widely used one, but you need to get the license. Okay, so its function is mostly doing the load calculation, shading and system sizing, like how many PV panels you will need. It can give you a very good idea. Then it will generate detailed performance report, and it's widely used. Like whenever the thing comes to which software I should use, so the most common answer is PVSys. And then comes the next one, system advisor model. The one good thing is it's free. You can download it and install it. Then it will actually handle some of your thermal, photovoltaic and thermal also. It will cover some of the thermal aspect also. Then it will combine financial and technical performance, and this one is good for techno-economic studies, and the best thing is it is free. Then Helioscope is not free, but it will give you the cloud-based PV design tool. Okay, so it's strong for shading and layout optimization, and combines the performance, financial modeling, and useful for commercial rooftop system. So the YouTube channel link is here. You can have a look if you want to see. They sometimes, especially PV Syst, they give you tutorial in YouTube. Okay, how to use that. So we are toward the end of this course and this lecture. I hope I could deliver something, but definitely I was not able to give you the full course overview due to many constraints from my side. I apologize that I was unable to like invest more time on you, although I should have. And from your side, I understand your difficulty, so we hope for the best. So in this lecture we have learned about the manually designing, how can we estimate the load in my house, then based on that load how should be the PV sizing, whether I want to choose the battery, what battery should I choose, through that example. Okay, you can actually try in ChatGPT for different scenario. It is very helpful. Then we have learned about the software tools, and definitely if you can do a better design you'll get better performance, but the cost will also sometimes go up, right? So all these methods actually they complement each other, like the software and the manual one, they complement each other. So that is all for today and for this course. So by the way, I just want to give you a recap on your final exam questions. I'm initially planning to give you 2 questions, each 50 marks. One will be summarized from lecture 1 up until lecture 5, thermal application. Like you have covered that for your midterm. So there will be another question from there. And the other one will come from the photovoltaic, basics of photovoltaic, how to install, how to calculate the load, all these things. Okay, so there will be 2 questions. I will be opening the questions soon in Moodle, and I'll let you know. So all the best. May Allah keep all of you safe. Assalamu alaikum warahmatullahi wabarakatuh.